Question 23. Write a balanced equation for oxidation of propan-1-ol to form propanoic acid using O to represent the oxygen from the oxidizing agents. State symbols are not required. So in this case, we write down our alcohol first, which is propan-1-ol, plus the oxygen in brackets. It is going to give us propanoic acid, which will be given here, plus water. Now, when we look at the right side, we can see we have two free oxygen atoms. On this side, on the left side of the reactants, we have only two. So we balance the equation by adding a 2 there, and that will be balanced. Question B. This has an asterisk, and it's asking us explain how the conditions used affect the rate of reaction and ensure that propanoic acid is the only organic product formed. In this case, we need to understand that when you have a primary alcohol, during the process of oxidation, it is first oxidized to form an aldehyde, then to now carboxylic acid, like propanoic acid that you're dealing with at the moment. So step number 1, you need to ensure that you have high concentration of the acid or high concentration of dichromate. This is to ensure that you have increase in frequency of collision, which will lead to high rate of reaction. Number 2, the higher the temperature, the faster the rate of the reaction. And this is because the particles gain kinetic energy, meaning that you have more particles having greater energy than the activation energy, which leads to more successful collisions. Use of excess or concentrated oxidizing agent, and this is to ensure complete oxidation. Also, the use of reflux, heating under reflux. This ensures that the oxidation goes to completion, where you have formation of propanoic acid and not the aldehyde. Option C, a student suggested using a universal indicator to check for the presence of propanoic acid. Give a reason why the results of this test is not likely to be conclusive. The color of the potassium dichromate will mask the color of the indicator. So what you're going to see will not be clear. Question D. State the color changes at the endpoint. The indicator that we're using is phenolphthalein. Therefore, the color of phenolphthalein will change from colorless to pink. The information that is given here will be very helpful when we go to the next questions. So we need to pay attention to a few things. First of all, the permitted range is between 1,000 to 3,000 milligrams per kg. If you have somewhere writing, note that down. 50 cubic centimeter sample of propanoic acid was extracted from 50 grams of the feeds. The sample was then filled up to, made up to 250 cubic centimeters, and only 25 cubic centimeters was pipetted and used in the titration. We have the 3 titers, 1, 2, and 3. If you look at this, the concordant values will be run 2 and run 3. Concordant values. The values that are close to each other. Usually should not be far from each other, not more than plus or minus 0.2. So this and this. Now to the next question. Suggest two possible reasons why theta 1 or theta for run 1 is greater than the other two thetas. And the first reason would be run 1 was a range finder, or the rough theta, to just find the range where the theta volume would be obtained. Then another reason would be the burette was rinsed with water. Therefore, when you added the acid, it was rinsed with water instead of sodium hydroxide. So when you added sodium hydroxide, it was diluted. So the first run was might be affected because of such. Question 3. The equation for the reaction of propanoic acid with sodium hydroxide is given. So we have this. Calculate the mass in grams of propanoic acid extracted. So the first step would be calculating the mean theta, and for this one we use the concordant values, which is 22.2 plus 22.1 divided by 2. That gives us 22.15 cubic centimeters. Step number 2 is finding the number of moles of sodium hydroxide, and we know that 1,000 cubic centimeters, which is equivalent to 1 pm, has 0.00668 moles. Then what about 22.15? Cross multiplying, so we get 0.00668 divided by 1,000. So that will give us a value of 1.47962 times 10 raised to power negative 4 moles. Those are the moles of sodium hydroxide. Find the number of moles of propanoic acid. We know the reacting ratio of sodium hydroxide to propanoic acid is 1:1. Therefore, the number of moles of propanoic acid is going to be times 10 raised to power negative 4. This is in 25 cubic centimeters. So now we find in 250 cubic centimeters. So we will ask ourselves, if 25 has 1.47962 times 10 raised to power negative 4, then what about 250 cubic centimeters? So 250 times 1.47962 times 10 raised to power 4 divided by 25. That gives us 1.47962 times 10 raised to power negative 3. That is the number of moles of propanoic acid in 250. Now we find the mass. Mass is equals to relative molecular mass times the number of moles. To find the relative molecular mass of propanoic acid, we add all the relative atomic masses of the elements making up propanoic acid. So that will give us 74 multiplied by 1.47962 times 10 raised to power negative 3. This is 7474. It is going to give us 0.109 grams. Question 4. Use your answer to determine whether the acid in the sample lies within the range, permitted range, for use in animal feed. Now we got our answer at 0.19 grams. So I'm going to just write it here, 0.19 grams of propanoic acid. We now convert this into milligrams. So it is going to be 0.19 times 1,000, which is going to give us 109 milligrams. Step number 2 is, now we know that 109 milligrams was obtained from a sample of 50 grams of the feeds. Now we ask ourselves, then what about 1,000? What will 1,000 have? So that will be 1,000 times 109 divided by 50. That will give us 2,180 milligrams per kilogram. Permitted range is 1,000 milligrams per kg to 3,000 milligrams per kg. Therefore, we can safely say this is within the permitted range. Our final question for this section C suggests how the feeds would be affected if the amount of propanoic acid was outside the permitted range. So the first is below. This would mean the propanoic acid will not be effective as a preservative, hence the feeds will mold very quickly. Then if it is above, the food will become corrosive, it will even affect the taste, and it's going to become toxic to the animals. That is section C, unit 2, June 2019.